So now, in this video, we're going to measure resistance with a multimeter. And so one of the settings is resistance. That's the omega symbol. Omega is the symbol for resistance in electronics. Something to remember. If there's numbers, set it to a number higher than you can expect to measure. Otherwise, you'll just, if it's set to a lower setting than what you're actually going to measure, you'll get that OL. So that means out of limit. Right now, there's, I believe this can measure 10 million ohms of resistance. One of the reasons why I bought this particular meter. They don't sell anymore though, so you know, it's kind of hard to find it. But in any case, that was above like 10 million ohms of resistance. Now we got much less right there, and you get a reading. These auto ranging ones also take a little bit of time to get to the range that best suits what you are measuring. So we have an LED up here. It has an on-off switch. We can measure that resistor right away. LEDs are not resistive components. You probably won't get any useful info by measuring the resistance of an LED. So you'll probably get a number. You may get a number, but you know, you got to learn about LEDs so to understand why you might get that number. But for the most part, they have a forward voltage. They're not resistance based. So we can go across here now because the resistor, because it's not connected to anything. So 214.1 or 0.4 right there. So these resistors have a 1% tolerance, but they're cheap. So it should only be about 1% higher or lower, or even spot on. Also, I may have kind of damaged them a bit. Accidentally got them too hot or something. That might have changed it as well. So we'll come down here. But yeah, they were cheap, so I wouldn't be surprised if they're actually more than 1% off, even though they claim to be 1% tolerance. Again, for protecting LEDs, doesn't matter. Doesn't matter if it's 210, 230 ohms right there. But if you notice something fishy with how much current you're getting through a resistor, you can measure its actual resistance. So again, this resistor, I didn't have to do anything. There's an on-off switch right there. So it's part of the circuit, but now the circuit's open. One end of the resistor comes to a dead end. You just don't want a voltage across the resistor when you measure it. And I don't think it actually damages the meter if you measure with the voltage across it, but you know, it may. You shouldn't do that on purpose. And yeah, before we go, there's another thing. So you got to make sure the resistor that you're measuring, usually that's what you're measuring when you're measuring resistance, is the only component that the probes are going across. If I parallel this resistor with the other one down there, we actually get less resistance. So there's two resistors. You would think that resistance would go up no matter what if you got two resistors. So they're both to the positive supply, and they both come to the same point. I know I'm kind of far back because we are going to keep an eye on the display. I can zoom in a little bit. So now we will see that it's going to be somewhere around 110. Probably a little bit lower because they were both a little bit lower than 220 when we measured them. And there you can see a bit lower right there. And so put them in parallel. The main thing is when you're measuring the resistor, if there's another path back from one end of the resistor to the other components along the way, they can end up giving you a lower resistance value. Be aware of that. So if you have a resistor in a circuit and for some reason it has a lot less resistance than you expect, look for other components that go from one end to the other. Again, resistance is not something you measure a lot. So, you know, maybe you do like at the beginning before you can read the color code. But reading color codes comes pretty quickly. This is 220, as I said before. Pretty simple with these blue LEDs. That's red, red, black, black, and then brown for 1% tolerance right there. And so red, red is 2, 2. So it's pretty easy to spot 2, 2 right there. And the multiplier, you get used to that pretty quick too. If it's black, that means there's no more zeros, 220. If it's red, that means there's 2 zeros. And so that would be 22,000 right there. If it's brown, then that would be one more zero. So 2200, 2,200. And so once you kind of get familiar with the common colors, you know, 2, 2 is common, red, red, you know, everything adds up pretty quick. It doesn't take much effort after that point to read the color code. So again, I made this kind of long for absolute beginners. Hope you enjoyed. Make sure you check out one of the other videos I'm posting on the screen, and check out links down below. They all help out a lot. I'll see you in the next video.